Good morning, students. So we are going to continue with our chapter. We have almost come to the end of the chapter. So let's look at some of the rules before we study the next topic. Now, these rules are quite familiar to you because you have been using this from class 7 onwards, and even before that some rules have been used. Okay, so these are very familiar rules, so let's revise these rules once. Now, a and b here are all integers, right? So let's look at the rules. The first rule is a plus b the whole square, which is a square plus b square plus 2ab. So whenever you see a plus b the whole square, you can use this, or whenever you see this, you can use this, right? So this is the first equation. Then the corresponding subtractive equation of this is a minus b the whole square, which is also a square plus b square. This sign changes, minus 2ab, right? And next one is a minus b into a plus b. So when you have two integers in subtraction and in addition and they are multiplied with each other, then you can use a square minus b square formula, right? And the last formula is a plus b into a c plus d. This is basically opening of brackets. Now look here, you can see that this term is inside a bracket, right? And this term is inside another bracket. So which means this is one term and this is the second term, which means this entire part has how many terms? Two terms, okay? Two numbers, okay? Because when you add these two, you will get one number, right? And when you add these two, you will get another number, okay? So that is why this part has two terms. And how are they? What is the operation here? Since there's no operation here, it means what? It means multiplication, right? Whenever you don't see any operation, it means multiplication. So a plus b is multiplied with b plus c plus d, right? So now let me show you how to open a bracket. Most of you might know it and some of you might not know how to open a bracket. So please look and learn, because we are going to be using this everywhere, right? So first, you take the first element of the first bracket and you multiply it with the first element of the second bracket. So a into c gives you ac, right? So what was the process? A into c gives you ac, right? Now the second one is a into d. And what will be the sign in between them? The sign in between them will be this sign, plus sign, right? So this sign comes from where? From here, okay? So a into c, ac, plus, because there's a plus sign here, a into d, we get ad, right? Now next is again the same procedure. You take the second element and you multiply it with the first one of the second bracket, and you take the second element and you multiply it with the second one of the second bracket. And where does this plus sign go? This plus sign goes to this side, right? So that is what we're going to use. Now look, b into c gives us bc here, and b into d gives us bd here, right? So that is how we open the bracket. So let's look at it once more neatly. So a into c gives us ac plus a into d gives us ad, right? Then we have the second element, b into c gives us bc plus b into d gives us bd, and these plus signs are coming from these two signs, right? Now if these were negative signs, correspondingly negative signs will come on this side also, right? So these four rules or these four formulas are very important while solving these questions, because we're going to be using these formulas all throughout this second portion of this chapter, okay? So let's go into the main portion. So we're going to study a couple of rules now. The first rule is root AB is equal to root A into root B, which means that, what is the rule? What is this A and what is this B and what is this rule? This rule says that if there are two integers, this A and B can be anything, any integers, right? It can be 1, it can be 2, it can be 3, it can be minus 2, it can be minus 100, it can be 1000, 1 lakh, any integer, right? So A and B are two integers, and AB means what? AB means A into B, right? Multiplied, right? So when two integers are multiplied and when you put them inside a root, it is the same answer as when you individually take the numbers and put the root and multiply them later on, okay? So that is what this rule is. So let's explain this, or let's look at this through examples. Now the first example is root 2 into 3. You can see 2 into 3, so this is A into B 2 into 3. Now look, 2 into 3, what will be the root? Root 6, yes or no? So root 6 is equal to, when you do root 2 alone and root 3 alone and then multiply it, then also you'll get root 6 itself. Okay, that is what they're telling us. So root 2 into root 3, 2 into 3 doing together and then taking the whole root is the same as 2 and 3 individually getting the roots and then multiplying it. Okay, so that is what this rule is. Now the second one is, again, second example, we have taken different numbers, 12 and 13, and you have to always remember that since these numbers are inside roots, we have to always take positive integers, right? A and B can never be negative integers. It can be 0 or positive integers, right? Now second one, 12 into 13. So here 12 into 13, doing it together and putting it inside a root is the same as root 12 taking separately, root 13 taking separately, and then multiplying them together, right? Now another example, root 7 into root 9. What can we do? Root 7 separately, root 9 separately, and multiply them. You'll get the same answer as root 7 into 9. 7 into 9 multiplied, how much do you get? 63. So 63, root 63 will be same as root 7 into root 9 if you check. All right. Now the next part, the next equation, the next rule is root AB divided by root is equal to root A by root B. Now in the previous one we have seen multiplication. Now here we are seeing division. So here a common fraction, that is A by B, a fraction comes inside the root. So when a fraction comes inside the root, you can separate the root and put it for individual elements, right? You can give the root to the numerator also, to the denominator also. So you'll get the same answer if you do this question in both these ways. Okay, so for example, if you see root 3 by 4 somewhere, then you can separate them. That is root 3 by root 4. You can separate these two, right? So that is what this rule is. Now for example here, if you can see, then you do not know what 18 by 64 is, but you know what 64's root is, right? So if you want to simplify this root 64 and you want to write 8, then it cannot happen. You cannot write 8 here when the whole root is there. So what will you do? You will put separate roots. How can you put separate roots? Because we know this formula exists, right? When there's a common root, you can always put separate roots. This is the formula. So using that, what can we do? We can give separate roots and then we can write this root 64 as 8, right? So that's what this rule is. Now the next one. Next rule is root A plus root B, root A minus root B. You can see that it's the same number, A, B, B, and all of it has root A, root B, only the signs are different, plus, minus, right? And what is the common sign here? Multiplication, because both are in brackets and there's no sign in between, so it's multiplication, right? So A plus B into, that is product of, multiplication of. So A plus B into A minus B is what? What is the formula? A minus B. So when you see this, you don't have to sit and solve this. Instead, you can just substitute this formula, that is A minus B. You can directly find out the value by putting A and B and subtracting them, right? For example, here, look at this. When you look at this, you can see root 2 plus root 3, root 2 minus root 3. And when you do not have to open the bracket like I showed you before, since this is the same number, that is root 2, root 3, root 3. And there's plus and minus, that is opposite signs, and they're in multiplication. So we can use this formula and we can write it as 2 minus 3, which is minus 1. So if you go to solve all these and sit, you'll be wasting your time, right? So instead you can use the formula and you can solve it and get minus 1 easily from this formula. Okay. Now the next one, again example, root 7, root 9, root 7, root 9. Both are the same numbers inside the bracket, and one is plus and one is minus, and common sign is multiplication. So definitely again this same rule can be applied here. Root A plus root B, root A minus root B. So that is A minus B. So here A is 7 and B is 9. So we put that 7 minus 9, right? So 7 minus 9 is minus 2. So we get the answer minus 2. Instead of solving this entire thing, we have got the answer easily through this formula, right? Now the next one more example, root 12, root 45, root 12, root minus root 45. So you can see the same numbers, plus, minus, and multiplication. So again the same rule, 12 minus 45. So this rule is very, very handy in solving the questions, as you'll encounter a lot of these kind of big calculations where you don't have to calculate actually. Instead you can use these formulas and you can solve them easily. Okay. So by hearting the formulas is one of the main things. So please make sure that you have by hearted this, and there's nothing to by heart it as such because these are all using the same rules that I showed you in the beginning. A plus b the whole square, a minus b the whole square, a plus b into a minus b, and a minus b, a plus b into c plus d, right? So those four rules are being used here. For example, here which rule is being used? A plus b into a minus b rule, that is a square minus b square, right? So the same rule was used here and then they came up with this equation, right? So that is the reason why this also became a rule, okay? So now if you did not understand what I said right now, then you don't have to worry about it. Just make sure that you know all the rules by heart, okay? So that you can apply it on numbers when this kind of things come inside the questions, okay? Now next one, fourth rule. Before, in the previous question, you can see that both numbers had root. Here only one number has root. The first number a does not have root and b has root. So a plus root b, a minus root b. You can see the same numbers, same terms are repeating. A, root b, and only the sign is different, plus minus, and the common sign is multiplication, right? So is equal to a square minus b. So is equal to a square minus b is the formula. So let's look at some of the questions now. The first one is 2 plus root 3 into 2 minus root 3 is equal to 2 square minus 3. 2 plus root 3 into 2 minus root 3 is equal to 2 square minus 3, right? So here a is 2 and b is 3, right? So therefore a plus root 3, 2 plus root 3, 2 minus root 3 will become 2 square minus 3 according to this formula. Instead of a I put 2, instead of b I put 3. So make sure that when you take b, remember that b is the only element inside the root. B is not root b, okay? So some of the kids, they make the mistake that when you take b here, what do? Instead of putting 3, you put root 3 and then you solve and keep. No, they're not asking us for root b, they're asking us for b. So look here, this is root b. So we need b. So b means the element that is inside the root, right? So make sure that you don't solve it carelessly, but instead watch out and solve it when you do the questions, all right? So the next formula is, so these are same examples. I've just given you the same examples. Look here, different numbers, so that it will be more thorough for you. 4 and 9, again 4 is a and 9 is b. So instead of solving this entire thing, we can just directly use the formula. So a square minus b, so 4 square minus 9, and you can find the answer, right? Here also again the number change only, 12 and 24, 12 and 24. Instead of solving this, you can solve directly using the formula. A is 12, b is 24. So 12 square minus 24, right? So now next formula. Next formula is this, which is root a plus root b, root c plus root d. Here you can see none of the numbers are same. Root a, it's not root a here, it's root c. Root b, it's not root b here, it's root d. So you can see a, b, c, d, different numbers but all in root, and they are all in plus, both side plus, right? So according to that, even if it's minus, it will be the same thing. They're normally opening the bracket only, okay? So how did I teach you to open the bracket? What do? You take the first element, you multiply it with this. Then you take the first element and you multiply the second one, right? Then what do? You take the second element and you multiply it with this, and you take the second element and again and you multiply it with this. So this is the formula. And how did you get this? So a into root c, root a c, right? Look, root a into root c is what? Root ac. One second. In the first formula, what did we see? We saw that root a into root b is equal to root ab, right? So this is what we saw. So root a into root c, see, look here, root a into root c, what can I write? Root a into root c, root a into root c can be written as what? Root ac, using the first formula, using the first formula or the first equation that we have seen before, right? So same way, that's why I wrote it directly here, root AC, instead of writing root A into C, okay? So root A into root C is root AC. Then we have root A into root D is root AD. Then we have root b into root c is root bc. Then root b into root d is root bd. Okay, so AC means A into C, AD means A into D, BC means B into C, and likewise BD means B into D. Okay, so now let's look at the formula being applied in the questions or being applied on numbers. Now I've taken different roots here, root 5, root 8, root 2, root 3, all different roots. So what do? You just solve it normally. So root 5 into root 2 will be root 5 into 2. 5 into 2 is 10. So 10, right? Now next is root 5 into root 3. Root 5 into root 3 will be root 5 into 3. So 5 into 3 is 15. So root 15, right? Now next root 8 into root 2 will be root 8 into 2, which is root 16. So root 16, right? Next is root 8 into root 3, which will be root 24. Root 8 into 3 is 24, right? Now the next one is root 3 into root 15, root 2 in plus root 7, root 3 plus root 5, root 2 plus root 7, right? So again we solve it. Root 3 into root 2, root 6, root 3 into root 7, root 21, root 5 into root 2, root 10, root 5 into root 7, root 35. So the same type. Okay, look at the question once carefully. Now the next formula is this: root a plus root b the whole square is equal to a plus 2 root ab plus b, right? So if you have root 5 plus root 6 the whole square, you can write this as, you can simply solve this as 5 plus 2 root 5 into 6. 5 into 6 is 30, right? 30 plus 6. Next one, 3 root 3 plus root 4 the whole square is 3 plus 4 plus 2 into 3 into 4, right? 3 into 4 is 12. So 2 into root 12, right? Next is root 7, root 2. So 7 plus 4, 7 plus 2 into 14, right? 2 into 14. How did 2 into 14 come? 7 2s are 14. So 2 into 14, right? So basically these are all just application of the formula, and you need to know the formula or learn the formula by heart in order to be able to use it while you're doing the questions. All right, so when you see root a plus root b the whole square, since you do not know the value of root 5 and root 6 and root 3 and root 4, etc., what are you supposed to do? You're supposed to use this formula so that you will be able to solve it, right? In order to remove the square, you need to solve it. So when you have to solve it, you don't know the values of root 5 and root 6 so that you can plus it, or you don't know the values of root 3 and root 4 so that you can plus it, right? So what do? You use this formula and expand it, and then you solve it. Okay, so like that you'll be able to solve it and you'll be able to arrive at your answer. So that is the reason why, that is the main purpose why we use these formulas, so that we can simplify something, so that we can arrive at a conclusion from the equation or the solution that we're doing or solving. Okay, so the next one we are going to delve into the chapter's important portion, which is, all of these portions have been important, whatever we have discussed, but this is one of the most important portions, which is rationalizing the denominator. Now look at the word rationalizing. What do you mean by rationalizing? Rationalizing means to convert into rational. Okay, something that is irrational you'll take and you'll make it rational. That is what rationalizing is. Okay, so rationalizing means what? To convert into rational. That's what rationalizing is. Now what will you convert into rational? You'll convert the denominator into rational. So that means you have a fraction where you have an irrational number as the denominator, right? Numerator, you have some number. You don't have to know about what the numerator is. But denominator, you have what? Irrational number. And you have to make the denominator rational number. So this process of converting the denominator into rational number from irrational number is called what? Rationalizing the denominator. All right, this process is called rationalizing the denominator. Now before learning rationalizing the denominator, before learning how to rationalize the denominator of a given fraction, we're going to look at what conjugate is. Now what is conjugate? Think about it. Conjugate means you have to reverse the sign. Okay, so this is the formulas which will show you what conjugate is. Now look, root a, suppose the conjugate of root a is minus root a. conjugate in its sense is actually like a reciprocal. Okay, so just know only that much. You don't have to delve deep into what conjugate is right now, but just know that the conjugate of root a is minus root a. Conjugate of minus root a will be root a. So this is, if a is root a is the conjugate of minus root a, then minus root a will be the conjugate of root a. Okay, so this works in both the ways. If this is this, that this is this. Okay, like that. So if root a is the conjugate of minus root a, then minus root a will be the conjugate of root a. Now likewise, look at this, root a plus root b. What is the conjugate of root a plus root b? Reverse the sign, root a minus root b. Root a minus root b will be the conjugate of root a plus root b. So same way, ulta also is correct. The opposite is also correct. A plus b, root a plus root b is the conjugate of root a minus root b. So like that, it's a root a minus root b. What will be the conjugate of root a minus root b? It will be root a plus root b. So you have to only change the sign. All the numbers, all the expressions will remain the same. Only changing the sign is enough for finding the conjugate, right? Now look at this, a plus root b. What is the conjugate? Change the sign, a minus root b. A minus root b is the conjugate, right? So now you understood what conjugate is. Okay, now very important, keep in mind what conjugate is, because all the next portions that we're going to do will be involving the use of conjugate. Okay, so keeping what conjugate is in mind, let's look at the next portion. So we have been told that we have to rationalize 1 by root 2. Now how do I rationalize the denominator? Let's look at the steps. The first step is to multiply the numerator and the denominator by the conjugate of the denominator. Now can you see this word conjugate? Conjugate of what? Conjugate of the denominator, right? So now look here, what is the denominator here? Root 2. So I have to convert this root 2 into a rational number. Okay, this root 2 is what kind of number? Irrational number, right? So I have to convert this into a rational number. That is why this process is called rationalizing, right? So we are going to rationalize the denominator, means this irrational number in the denominator, we are going to convert this irrational number into a rational number. Okay, that is what this process is, right? So now 1 by root 2, as you can see, what are we going to do? We are going to take 1 by root 2 and we are going to take the conjugate of this denominator. What is the denominator? Root 2. Root 2 is the denominator. The conjugate of root 2 is, clearly I know from before I told you, if root a is it, then what is the conjugate of root a? Minus root a. So here root 2, then what is the conjugate of root 2? Minus root 2, right? Only the sign will be opposite, the number will be same, right? So root 2's conjugate is minus root 2. Now I'll take the conjugate of this denominator and I'll multiply it in both the numerator and the denominator. I'll have to multiply it in both the numerator and the denominator. Okay, so this is what process we are going to do. So let's see it step by step. How do I rationalize it? How do I convert this root 2 into a rational number? Let me see. Okay, now so look at this, root 2. Root 2's conjugate is minus root 2. So I took minus root 2 and I multiplied minus root 2 on the numerator also and on the denominator also, right? So what do I get? Now I have to multiply it directly like this. So 1 into minus root 2 is minus root 2. Then 2 into minus root 2 is 2 into minus root 2, right? Now look here, one general thing that I want to tell to you. We have already known this from class 7 itself. We have been studying about this. 5 into 3 is how much? 15, right? So 3 into 5 is how much? 3 into 5 is also what? 15 itself, right? So can you see, if I change this position of the numbers, if I put the numbers in different positions, will the answer change? No, the answer will not change. Because why? Because it's multiplication. If it's addition or subtraction, it will change. The sign of the number will change, right? But if it is multiplication, not this, even the sign also will not change. The answer also will not change. So we can interchange the numbers when we multiply, right? So that's why look here. This root 2 into minus root 2 can be written as minus root 2 into root 2, right? So let's look at the next step once. Now what did I do first? First I took the conjugate of the denominator. The denominator here is root 2. So I took the conjugate, that is minus root 2 and minus root 2, and I multiplied it both in the numerator and in the denominator. Then after doing that, what did I do? I directly multiplied it, which is 1 into minus root 2 is minus root 2. 2 into minus root 2 is I can write this as minus root 2 into 2. Why? Because if I interchange this, not going to happen. The change is not going to happen. Same answer you will get, right? So 2 into minus root 2 is also, 2 into minus root 2, root 2 into minus root 2 is the same as minus root 2 into root 2, right? And why is that so? Because I've told you already 5 into 3 is 15, right? So likewise 3 into 5 is also 15 itself, right? So the same thing that we're applying the same technique here, okay? So we're changing that for our convenience, okay? So now let's look at it. So what was the step? The first step was I took the conjugate of this, I multiplied it in the numerator and in the denominator. Then I multiplied it straight, right? So 1 into minus 2, minus 2. Root 2 into minus root 2, I changed their positions for my convenience, so no problem. Now as you can see, there is no plus or minus sign in between any of this, right? In between any of this, there's no plus or minus sign, which means that all of this is in multiplication and division only. So which means I can easily cancel this minus and this minus, right? So I'll cancel out this minus sign and this minus sign will be cancelled. And what will be I left with? I'll be left with only this much portion, right? So this much portion, when I solve it, what do I get? Root 2, I don't have any number to multiply it with, so it will remain root 2 itself. But here, root 2 into root 2 is how much? Root 2 into root 2 is how much? 2, right? So this one you have to know and keep. This is a formula, right? Root a into root a is root a into root a is a, right? Why is that so? What is the reason behind that? Because root a into root a can be written as root into a, right? The first formula that we saw, right? The first exponent, the first root a into root b is equal to root ab that we saw, right? So like that itself, here instead of b it's a itself. So root a into root a, root a, right? So a into a is what? A squared. So I can write this as root a squared. Now when I write root a squared, square and square root will cut. What will I get at last? I'll get a. So basically root a into root a is, you can see here, root a into root a is a itself, right? So that is the reason why here root 2 into root 2 became 2, okay? So do not get confused. If you are confused, please watch this part of the video again. Root a into root a is a. And what is the reason? I have shown you via an example. So root 2 remains the same because it does not have any number to calculate with or to lessen or increase with, and here root 2 into root 2 becomes 2. So now if you look at this, you can see that the denominator that was once root 2 has now changed to what? The denominator that was once root 2 has now changed to 2. So can you see? It changed from an irrational number to a rational number. 2 is a rational number, right? Why is 2 a rational number? Because 2 can be written as 2 by 1. Yes or no? So 2 is a rational number. So root 2 was irrational, but I converted this root 2 into 2 by 1, which is rational. So that means I converted an irrational denominator into a rational denominator. So that is why this process is called rationalizing the denominator. Okay, so that is why this process is called rationalizing the denominator. Now let's look at some more examples to make it clear. Now remember that the question that you have been given, that is 1 by root 2, we did not do anything to 1 by root 2. We have only done the steps and we have arrived at this. But this means what? What does this mean? What does this question mean? When I took 1 by root 2, at last I got this. That means what? It means that 1 by root 2 is the same as root 2 by 2. How is that so? Let me show you. Now look here, root 2 by 2 can be written as what? Root 2 by 2 can be written as root 2 by 2 can be written as root 2 into root 2, right? Root 2 into root 2. Now can you see root 2 and root 2 will go? What is left on top? Only 1 is left. So that is basically 1 by root 2 itself. So that means 1 by root 2 itself is root 2 by 2. It's a very different way of writing. It's only the different way of writing. This is written as this, but these are both equal, okay? So that is what? It's only the way of writing, right? For example, I can write apple in any way I want, right? I can write it with a green pen and with a red pen, but the word will be the same. So like that itself, 1 by root 2 I am writing and root 2 by 2 I am writing. It's the same thing, but only the way of its appearance is different. So that is why this is called rationalizing the denominator. We have converted the denominator from an irrational number to a rational number. That is why it's called rationalizing the denominator. Alright. Next portion. Now let's rationalize this. Look here. We have 1 by root 7 minus root 6. So this is 1 by root 7 minus root 6, right? So how do we rationalize this? Now 1 by root 7 minus root 6 will remain the same, and we take the conjugate of the denominator. What is the conjugate of the denominator? Root 7 minus root 6. So we have to change the sign, right? What is the sign? It is minus, so we have taken plus. So when we take plus, it becomes its conjugate, right? So what is the conjugate of root 7 minus root 6? It is root 7 plus root 6. So we took the conjugate first, then we multiplied on top, and then we multiplied below to the numerator and the denominator. Then we multiplied straight. 1 into root 7 plus root 6 is root 7 plus root 6 itself, because 1 into anything is that thing itself, right? 1 into 2 is 2, 1 into 3 is 3, like that. 1 into root 7 plus root 6 is root 7 plus root 6 itself. Now root 7 minus root 6, root 7 plus root 6. So that one into sign is there. So we'll put it like this, root 7 minus root 6 into root 7 plus root 6. Now when you put two brackets and have no sign in between, what does it mean? It means into itself, right? So that is why we have written it like this. Now look, now you have this. Look, upside you cannot do anything. You don't know what the value of root 7 is, you don't know what the value of root 6 is, and none of the formulas can also be applied, right? So you just leave as it is, root 7 plus root 6. Whenever you rationalize the denominator, remember that the numerator is not of much importance to you. So please do the basic solving of the numerator, but beyond that, don't try to find out the value of root 7 or root 6. Do not worry about that, okay? The main point, the main aim is to bring a rational number in the denominator. These are both irrational numbers. So when you subtract two irrational numbers, you will get another irrational number, right? So that's why our main aim is to rationalize the denominator. So we don't have to think about what is in the numerator. So just leave the numerator as it is for now. Now look at the denominator. Denominator is root 7 minus root 6, so root 7 plus root 6. Now what do you do? How do you solve this? You either open the bracket directly, or instead of doing that, that is the longer method. Instead of doing that, what do? You compare it to all the formulas you know, right? So when I compared, I got that it is similar to this formula. Where root 7 I can treat it as root a, right? Root 7 I can treat it as root a, and root 7 I can treat it as root a. Then root 6 I can treat it as root b. Then root 7 again. So you can see root 7 plus root 6, root 7 minus root 6, right? So this is the reason why I've used this formula, and according to this formula, root 7 plus root 6, root 7 minus root 6 will become a minus b. A minus b is 7 minus 6. Whatever is inside the root, you have to subtract it, right? So using this formula, what do I get here? In the second step, instead of root 7 and root 6, root 7 minus root 6 and root 7 plus root 6, what can I write? 7 minus 6, because this is according to the formula, right? So once more I'll explain this part. Look here. First, what did we do? We wrote the question, then we took the conjugate of the denominator and we multiplied it in the numerator also and in the denominator also. Then after that we multiplied this. 1 into this will be this itself, so you write as it is, root 7 plus root 6. Now after that you multiply this 2. When you multiply this 2, how will you multiply? You put them in separate brackets and you put a multiplication symbol in the middle, right? Now if you don't put anything also, it means multiplication itself, so you don't put anything. Now you look at this, you don't know how to solve this, so what do? You look at the formulas. So look at here, root 7, root 7, root 6, root 6. So it's the same numbers inside the bracket, only the sign is different, right? So you can see that this is the same as this formula, root a, root b, root a, root a, root b, but only the sign is different. So what is the formula? A minus b. So like that itself here also, root a, root b, plus minus. So you can use this formula, which is a minus b. So a minus b is because here it's a and b. Here 7, 6. So it will be 7 minus 6. So we wrote 7 minus 6, right? Now root 7 plus root 6 will remain same again, and 7 minus 6 is definitely 1. So we can write this as root 7 plus root 6 divided by 1, which is root 7 plus root 6 itself. Why? Because any number divided by 1 is that number itself. 3 by 1 is 1. 3 by 1 is 3. 5 by 1 is 5, right? So likewise, root 7 plus root 6 by 1 is root 7 plus root 6. So that is how we got this. Now look at here. What is the denominator? 1. So the denominator changed from root 7 minus root 6 to 1. So can you see the transition? Here it was an irrational number, and when we got the final form, it became a rational number. So this is why we call this rationalizing the denominator. This is why we call this rationalizing the denominator. Alright. So now the next portion, the next part of the class we'll be doing in the next video. Alright. So until that, please revise all the formulas and make sure you know all the formulas properly and you have watched this video so that you will be clear with how to rationalize. In the next video, we will be doing lots of other questions similar to this about rationalizing. We'll be continuing with rationalizing the denominator itself, and we will be doing the exercise 1.3. Okay. So make sure that you watch this video, alright, properly, and learn and keep, unless you can come to the next video and watch it. Okay. So see you in the next video. Thank you for watching.